So we have a bunch of variables here that we've worked with so far. We've worked with integers and floats, strings and a Boolean, but often the variables that we have in the real world are not single items, but rather collections of things. And what do we do with those? Well, it turns out that Python is especially good at working with lists of things or other kinds of collections. This is, in other languages, sometimes you have to assemble these in various ways to make them work, but it's really the basis of what a lot of Python works on. And so, although we'll be using other toolkits to extend this a bit and to do other things with it, generally speaking, the core stuff that Python comes with is really well suited to dealing with lists. So let's deal with a list. Let's go ahead and add one in. And frankly, normally you wouldn't do this kind of assignment of a list directly in Python, right? Because the lists are going to come from somewhere else. But you can just type out a list like this. So this is our handy assignment operator, the equal sign. And then you'll see there's square brackets on either side of the list. And then in this case, we have a list of some other kind of variable, right? In this case, it's a list of strings. So these are our names. And if we hit enter, well, actually control enter, it goes ahead and thinks for a while because it needs to do that when it's fresh. And it's done doing that. And now we can kind of go ahead and take a look and see what happens when we ask about that item. Oops. And there's our list. All right, so we have this list, and there's lots of things we can do with a list. For example, this is the full list of users. We could do something, for example, we could, we already know this works as a function of the len of our list, which is users, right? So we can do that. And it'll tell us that there's 8 items altogether. We can use brackets to address individual items in this list. So we can, for example, ask about users, and we might want to look at users 4, right? Because I hit that button, for example. And so if we do that, we end up with Eve. Now, this is one of those other tricky things that you just have to get used to. If we counted these out, 1, 2, 3, 4, 5, we would expect Eve to be in the 5th position, but the trick is, let's take a look at what's in the first position here in 1. If we ask for what's in the number 1 item in this, it's Bob. But this is actually the 0th item. Now, why? Because. Because that's just the way these things work. So the 0 index item is the first in the list. And so this is 0, 1, 2, 3, 4, 5, 6, 7. We can also actually get at the last item by doing, we can do -1, for example, and that will get us Zeno. So, or if we want to do the second to the last item from the list, we could do -2. And that'll get us this Bob right here. Note that there's 2 Bobs in this list. And lists can have multiple items that are the same, multiples of the same item. They don't have to be strings, by the way. We'll get to that in a second. They could be integers. They could be floats. They could be Boolean. They could even be lists, which is important. So we can do count for Bob. This is one of the it's a weird kind of construction we haven't seen before. So we have seen things like len as a function. This is kind of like a function. Python's a little unusual in that you can use both functions and you can use what are called methods, which are something we'll get to a little later down the road. It's how you address built-in. Oh, there we go. It says built-in sorts of functions that apply to a particular object. In this case, users is the object. It's a list object, and these are the methods that can apply to it, the dot something. And so count is kind of like a function, but it is built into this particular object of users. If that's confusing for now, don't worry about it for now. Just kind of get used to the fact that you can do this thing to this list. It's kind of a built-in thing that you can do to that particular object. And one of the things that you can do is count items in that list. So we can count Bob and we get 2 because there's 2 of them. But if we count Alice, we're only going to get 1. And if we count George, if I can spell George, we get 0 because there's 0 Georges in our list. So good. There's some other things we could do as functions, or rather as methods. We can sort the list. Oops, control. And now if we look at users again, let's take a look at users. You'll see that we have Alice, Bob, Charlie. So all it did, it was already in close to alphabetical list already. It was just Bob was out of order here, so it's moved Bob up to the front. We can then, if we like, users, we could reverse that. I don't know why you'd need to reverse it. I can think of some reasons you might want to, but we can reverse it. And we get it in reverse order. We could look and see what the index is for individual items. So we can kind of look, this is kind of like a search for it, right? We could do an index and look for where, say, Dutch is in this list. Oops, I've kind of done that in a weird place. That's okay. It'll still work. And it'll give us the third item. We don't have the list right now. That's not the order it's in anymore because remember we reversed it, but that's okay. Dutch is not the third, it's the third item, but starting with 0. So keep that in mind. So it would be the 4th over from the left. Let's see. We can also get, we did this before when we were looking at individual items. Remember we can use, this is using some methods, and there's a whole set of methods. We can, one of the ones that we would use, we've hit the big ones, and actually we don't use reverse very often, but we might use append more often, where we have a list of things and we want to add in an item, and we could call it sort of, I don't know, we were FG, we could add George in. We didn't have George. Again, I have to spell him, but we can add George in, and that adds him to the list. And let's go ahead and take a look here at users. So George is added on to the end here. We could also try doing this, right? We ran into this the last time around. We could try doing we could try to spell it. We were doing EFG Harry. Not that you have to do these alphabetically for any reason at all. And then if we take a look at users. It's only gone down like this because we have too many items. It doesn't quite fit across. That's the only reason it's gone down. But you'll see we have a problem here. It added Harry really weird, right? So that's messed up our list for one thing, but it's also why we don't use this. And the reason for this is my name is Harry. Oops, needs quotes. Harry, right? Is that even though this is a string, it also can be treated like a list. So we can say my name, for example, my name, and use these same brackets and do the number 1 letter in there, and it's going to give us A. Remember, this is the number 1 letter. This is the 0th letter is H, the first letter is A. So my name 1 is A. So that's why you can't really use the plus equals here. It tried to do it, but it failed by adding all that garbage, right? So let's take a look and see. We could just go up here and reset it by hitting that. But that's probably the easiest thing to do, actually. So let's go back to where we were. Now if we take a look, we can, if we look, I've kind of set it to that. So if I look at users again, it'll be there. But one of the things we could do is get a list of the items in users, right? And so this is a list, but we can do bits of it. We've done an index where if we did 1, we would get Bob. But if we went from 1 to 5, that's not including 5, okay? So that's a little bit confusing. I don't know why, but it's the way it works. So this is 0, 1, 2, 3, 4, 5, 6, 7, right? So if we do this, which is a list within the list, it's the items including 1, 2, 3, 4, and not including the 5th item, so stop at 5. And that's kind of a subset of it. If we leave this off entirely, if we just say 1 and don't have a closing, it will give us everything from 1 to the very end. Or we could go the other way around and say, we could go through from wherever through the 5th, right? And that'll take us up to, but not including Frank. Or we could do it, if we wanted to include everything but the last item. Remember, -1 is the last item on the list. So this is everything up to, but not including the last item. We would get Alice all the way through that Bob, but leaving off Zeno. So we can do lots of things to kind of get at various pieces of the list. And lists end up being really important. I'll just leave it there for a second. We're going to come back to lists in a second. But I'll note that we have another really important way of doing collections. And I should kind of insert myself here to say there's actually a bunch of different collective variables. This is the and friends up here at the top that we're not going to touch on. For example, there's what's called an immutable object called a tuple. And tuples are kind of like lists, but you can't really change them in the way we've been doing here. They're usually lists, but within parentheses. And you use them mostly for kind of indexing and labeling things. There's sequences. There are, as we'll get into some other things like arrays and frames later on. But for the main lists, the ones that we use the most, they're going to be the main kind of collections, I should say, variables. There's going to be lists and dictionaries. So this is a list. It's denoted with those brackets. Let's say that we wanted a list, but we wanted a list of people by their name. We wanted to know kind of how old people were in a list, right? So we're going to use for that something called a dictionary. So I'm going to, again, we don't usually in the code define this stuff. Normally we would be getting it from somewhere, from a database, from a file, from somewhere, right? But in this case, I've got a bunch of ages of individual people. So remember, for getting at the users, what we would do is we would put in the 0th, 1st, 2nd, like we could go to an index item and get that person. We also had a bunch of methods we could use. For dictionaries, what are called the keys, the things that we use to look up stuff, aren't numbers or indexes, but are those first items. So we can get, for example, Bob's age by doing that, and it spits out 65. So in other words, it's a way of looking up things that are indexed by the person. You know, if you have a telephone directory in your phone that lets you know what people's phone numbers are, you could have that, their names and then their numbers or something like that. Now the issue here is you can't have more than one Bob. Because Bob is our key, you can only have one Bob in the list. If you had another Bob, they'd have to have a different name, or you'd have to do something. These have to be unique. In other words, you can only have one of them and have this work for the string. As with the others, these can be anything. They could be, we could do like, we could have this be, instead of age, we could have it be partners, for example. And Alice has Fran as a partner, and Bob has Claudette as a partner, or whatever, right? Like this could be string to string. It doesn't have to be that. Or it could, in fact, be from string to a list. And that happens quite frequently. So let's just say I have a bunch of students in a class. I do, that happens. Let's start with an empty one, and we'll do like grades. Everyone's favorite subject. So let's say I'm going to start an empty dictionary, which is just this. We've run into this before as an empty string. This is just saying this is going to be a dictionary. I'm going to treat it as a dictionary, but it doesn't have anything in it yet, right? And then we can start saying things like the grades for one person. So recall that we use brackets to access the person, and we could say me. And then my grades are going to be not a single grade, but rather a list of grades, right? So I'm going to do a list, and let's do them as letter grades. I only get A's, but let's just throw in a D in there for good measure, and a gentleman's C, right? So, and I'll hit this. And then if I take a look at grades, I'll do a new one right here real quick. Take a look and see what grades looks like. And you'll see I only have one item, but it's here's the index, Alex. This is the dictionary key. And then it's attached to a list of things. So this getting at those items could be a little complicated. In this case, I only have one thing, but I still, to get to it, I'd have to do, for example, grades, Alex, and then I've got a list. And remember, to get to lists, I'd do an index. So maybe I would want to look at the first item on that list, and I could do that. And that gets me the A, the first item on that, the 0th item on that list, rather, right? Or maybe I would want to do, we can do the same methods we were doing before, because this is a list. So, oops, I didn't mean to type method. I meant to type count, and maybe we want to see how many C's I have, right? So we could do that and find out that I have one C in my list of grades. So those are the two major ways that we use to collect, to deal with collections of data. And we'll see that these can be really powerful, and there's lots of things that we haven't touched on at all. This is a whole topic in and of itself. Ways of constructing these, ways of constructing ones that are partially structured in some way. There's lots of kinds of ways of creating them on the fly. For example, if you want to create them programmatically, so you have a list of prime numbers, for example, there's ways, that would be a little tricky, but there's ways of doing things called list compressions, where you have a very short piece of code that creates a whole list of things. And so we really only scratched the surface of both lists and dictionaries here. As we go forward, you'll see we'll use these probably more than, we have single variables that we'll use for various things, but these collections of things are super important. When you read in a file, for example, in many cases, you'll read them in as a list of lines, because it's easier to process that way. There's lists that are a special kind of collective that kind of moves as you're collecting them, and those are pretty common in some of the projects we'll do, because you're kind of collecting things into a list and then processing it as you move forward. So there's lots of complicated things you can do with lists, but this gives us a first step in how we use lists and dictionaries, both of those. All right, thanks.